All right, let's dive in. Today, we're talking about a project that sits at the intersection of two of the most mind-bending technologies out there, cryptocurrency and quantum computing. And believe me, it sounds like something straight out of science fiction, but it is very, very real. So here's the big question, the one that got me so interested in this whole thing. Can the massive global power of crypto mining actually be harnessed to help build a quantum computer? It's a pretty wild idea, and the way it works is even more fascinating. Okay, so to really get what Qubitcoin is trying to do, we first have to understand the massive problem it's trying to solve, and that is the quantum simulation problem. Look, simulating quantum computers on the computers we have today, our classical machines, is absolutely essential. We don't have huge, perfect quantum computers yet, so these simulations are our playground, our laboratory for figuring out the software of the future. But there's a huge catch. Every time you add just one single qubit to the system you're simulating, you double the amount of computer power you need. It's an exponential curve that goes vertical almost immediately. Simulating even pretty modest quantum computers requires an insane amount of resources. And that creates this massive tension, right? On one hand, the demand for these simulations is exploding. There's tons of money and talent flooding into the quantum space. But on the other hand, the hardware you need, we're talking giant GPU clusters, is super expensive and basically owned by a handful of big companies and labs. So you've got this huge growing gap between what researchers need and what they can actually get their hands on. So, with that problem laid out, let's talk about the solution. And it is a pretty radical one, coming from a nonprofit research group called Superquantum. So let's get the name straight, because it's important. You've got Superquantum, they're the brains of the operation, the nonprofit with this big dream of open, accessible quantum computing. And then there's Qubitcoin. That's their tool. It's the blockchain they built from the ground up to make that dream a reality by getting people all over the world to pitch in. And you really can't say it any clearer than the co-founder himself, Mikhail Shaliginav. The goal is to decentralize the development of quantum computers. And that's a key distinction. They're not trying to build one physical machine in a million basements. They're trying to farm out the critical simulation work that everyone in the field needs to do. Okay, so this is where it gets really clever. This is the technical heart of the whole project. How in the world do you get a cryptocurrency to do useful scientific work? Well, the answer is something they call quantum proof of work, or qPoW for short. First, think about how something like Bitcoin works. The miners are basically a world full of computers racing to solve these incredibly hard but, well, abstract math puzzles. Now, that work is crucial for keeping the network secure, but the computation itself is, by design, useless. It doesn't generate any data that's valuable outside of just, well, mining more Bitcoin. Qubitcoin flips that model completely on its head. Instead of a pointless puzzle, the work that miners have to do is run a standardized quantum circuit simulation. It's that simple. They run the simulation, they get a result, they hash that result, and that hash is their proof of work. The very act of securing the network creates valuable scientific data. I mean, when you put them side by side, the difference is just night and day, isn't it? The byproduct of traditional proof of work is basically wasted electricity and heat. The byproduct of quantum proof of work is valuable simulation data. One has zero use outside its own little world. The other is designed to be useful for the entire field of quantum research. It's a fundamental change in what crypto mining can do. So what happens when you get thousands of computers all over the planet, all running these same standardized simulations? Well, you get something incredibly powerful. You get a global, decentralized engine for benchmarking performance. And listen, this isn't just some theory in a white paper. It's actually happening. Since the network launched, it's been buzzing with activity. The hash rate, that's the total computing power, is way up. More and more miners are joining in, and people are even developing different software to compete. It's a living, breathing computational ecosystem. And if we peek under the hood, the tech is really smart. They've integrated NVIDIA's Quantum SDK, which is a huge deal. It's pretty much the industry standard for this stuff. This means miners aren't just competing on who has the beefiest hardware, they're also competing on who can write the most efficient software. It creates this amazing competitive environment that actually pushes the science of simulation forward. But here's where it could get really interesting down the line. This whole system isn't just for classical simulations. You can take those exact same standardized circuits that the miners are running and run them on the real deal, actual quantum computers from companies like IBM and IonQ. Suddenly, the Qubitcoin network becomes this universal yardstick for comparing everything, from a gamer's PC in their basement to a multi-million-dollar quantum computer in a lab. So all of this, it leads to a much bigger question, doesn't it? Is this more than just a cool crypto project? Could this be a new way we think about funding and doing large-scale science? And the first clue about how they're thinking long-term? It's this number right here, roughly 21 million. Now, if that number rings a bell, it should. It's the exact same capped supply as Bitcoin. That's not an accident. It's a signal that this thing is built with scarcity and the long haul in mind. And the economics of the whole system are built to serve the science. It had a fair launch, which means no big bags of coins were set aside for insiders at the beginning. The rewards are tied directly to getting computational work done, not just having the clock tick by. It's a system where the value is directly linked to the scientific progress being made. You know, when you boil it all down, that's what this really is. It is a grand experiment. Can you take the incredibly powerful, decentralized incentive machine of cryptocurrency and perfectly align it with the real-world, practical needs of cutting-edge science? And that's the question we're left with, isn't it? Is this a blueprint for how we're going to fund massive scientific projects in the future? Or is it a brilliant but ultimately niche experiment that will become a fascinating footnote in history? Honestly, it's way too early to know for sure. But it is, without a doubt, one of the most interesting things happening at the edge of science and technology today.